Nature is beautiful and full of mysteries we cannot completely unravel. The more we understand nature, the more we are exposed to mysteries. Not just mysteries, beautiful mysteries, unimaginable mysteries, and mysteries beyond our comprehension. You are welcome to Dynamic Educational Hub channel. This is a channel where I dissect various topics in physics, chemistry, and mathematics. If you are just coming across my channel, kindly subscribe to this channel and click on the notification icon to get notified when I release new video. What are we learning in this video? This video is a continuation of the former video, so we are going to start by solving the former quiz. Then after that, we dive into learning Pythagoras Theorem. So we are going to prove Pythagoras Theorem and learn a lot in Pythagoras Theorem. Not just Pythagoras Theorem the way you know it, we are going to use another dimension to learn Pythagoras Theorem. Even if you understand Pythagoras Theorem, kindly watch this video to the very end as it is full of many things that you are going to enjoy. Without further ado, let's start the lesson. So the first question, we want to convert 60 degree to pi and to radian. Now converting 60 degree to pi in radian, we have 60 pi over 180. Multiply 60 degree by pi over 180 degree. So we get pi over 3. Now 60 divided by 60 we have 1, and 180 divided by 60 we have 3. So 60 pi over 180 is pi over 3. Converting it to radian, we have 60 multiplied by 0.01745 rad, because 1 degree is equals to 0.01745 rad. So our answer is 1.047 rad. So the next question is 30 degree, and 30 degree is 30 pi over 180 in radian, and we have 30 divided by 30, 180 divided by 30, that's 6. So we have pi over 6. And 30 degree in radian is 30 multiplied by 0.01745 rad, and that is 0.52 rad. Next question, which is 90 degree, and 90 degree is going to be what? 90 pi over 180 degree. And you divide 90 by 90, you have 1, and 180 divided by 90, that's 2, that's pi over 2. And in radian, we have 90 multiplied by 0.01745, and that is 1.57 rad. Now to the last question, which is 135 degrees. So we have 135 pi over 180, and 135 divided by 45, that is 3, and 180 divided by 45, that is 4. So we have 3 pi over 4, and in radian we have 135 multiplied by 0.0175, and that is 2.36. Now we found the value of all these angles in pi, in radian, and in pi as well. So after we've learned measurement of angles in degree and in pi in radian, so the next thing to learn is a natural theorem, an amazing theorem in mathematics, which is Pythagoras Theorem. Now this theorem is from clear observation of triangle, right angle triangle. It's a natural theorem that is so amazing. So Pythagoras, who derived this theorem, who was able to give this expression, mathematical relationship between the 3 sides of a right angle triangle. So when we have 3 sides of a right angle triangle, they always conform to this theorem. If it is right angle triangle, this theorem is true for them. Now to learn Pythagoras theorem, I will not just tell you that a square is equals to b square plus c square. So I'm going to give you the background knowledge. Let's see how we can prove Pythagoras theorem. So make sure you watch this video to the end. This is absolutely interesting. Now let's have a mesh as shown. To prove Pythagoras theorem, you will need a graph. Now we have a mesh as shown. Now each box from this mesh is a square of the same length. So this is a square here, each box here. Since we are not using any measurement, so any measurement we take here, we call it unit. Each box here is a unit box. 1 1 1 each, so a unit box here. So we don't have subdivision in this box. So let's pick 2 points here. So we want to form right angle triangle. Picking these 2 points here, we have how many units? Let's join the 2 points together. This is a straight line vertically upward. 1 2 3, so we have 3 units. So let's pick another point here. Let's count it 1 2 3 4, which is what? 4 units. So let's try to join the 2 ends together to form a right angle triangle. So we join it together, so we have right angle triangle. Now the next thing is to measure this length. How do we measure this length? It is somewhat difficult, but not difficult with how I'm going to do it. The next thing is we are going to rotate while keeping this point here without increasing the length of this third side. We need to rotate it. Now rotating it, so we have rotated it up to this point, so we can measure the length. How do we now measure the length? Let's count the number of boxes. 1 2 3 4 5. So it means that this is what? 5 units. So the third side has been rotated up to this point and it's 5 units. We can all see it with our eyes. So let's use another triangle. Now we have points here, we also have points here, we have line. So let's count the number of units, the length of this. 1 2 3 4 5 6. So we have 6 units length. So let's form another point here. Let's count it. 1 2 3 4 5 6 7 8. So we have 8 units length. Now we have a right angle here between them. So let's join the 2 ends together. So this 8 units. So let's join it together. Joining it together, we have this. So how do we go ahead and measure this third side? We need to rotate it like we've done here. So let's rotate it. Rotating it, let's try to count the number of boxes here. We have 1 2 3 4 5 6 7 8 9 10. So we have 10 boxes here. So which means 10 units. The third side is also what? 10 units. We have 3 units, 4 units, 5 units, 6 units for this one, 8 units for this side, and 10 units here. So let's draw the third side back that was rotated. For this one, this side is still the same thing as this side here. The same thing, this side, this third side is still the same thing as this here. So let's do away with our graph here or our mesh, and let's have this. Now let's look at the mathematical relationship between all these sides. And let's start with this small triangle. Let's find the square of this side plus the square of this side. So which is 4 square is 16, 3 square is 9. So 16 plus 9. And let's find the square of this third side here, which is 5 square, which is 25. Wow. What is the addition of 16 plus 9, which gives us 25? So it means that 4 square plus 3 square will give us 5 square. This side square plus this side square will give us this side square. So 5 square is equals to 25. And 5 will now be equivalent to what? Square root of this side square plus this side square. And what is 4 square plus 3 square? We all know that it's 25. So let's move to the second triangle here. The same thing is applied with this second triangle. And let's find the value of the square of this 6 square plus this side square 8 square. 6 square is 36, 8 square is 64. And let's find the value of this third side square, which is 10 square. Now if you look at it, 36 plus 64 itself is 100. And what is the square of this 10? 10 square is what? 100. Since 10 square is equals to 100, we now see that there is relationship between all these 3 sides. And 10 will be square root of 6 square plus 8 square. So let's have a proper graph so that we can take care of the decimal. Pythagoras theorem is not only true for whole number, so we can use it for numbers that are not whole number, which is decimal number. So the same way, we'll still get the same thing. Now let's go ahead and use this graph. This is a perfect graph as well. Each box here is a unit, and each of these subdivision boxes, which are very small, they are 0.1 unit. So let's see how to use it to prove Pythagoras theorem. Proving Pythagoras theorem, let's pick 3 points here. These 3 points will form a right angle triangle. So we need to count the number of the box to fix the length. Now let's join these guys together. So let's go ahead and count the box. 1, 2, 3, 4, 5, 6. Then we have subdivision here. If you count the subdivision, we have 1, 2, 3. So that is 3 here. So we have 6.3 units. For this one, let's see how to count it to fix the length. We have 1, 2, 3, 4, 5. Let's count the subdivision. We have 1, 2, 3, 4. So we have 5.4 units. So let's join the two ends together. So we have a right angle triangle. So to measure this length as well, we need to rotate it. So let's rotate it to form an angle, and we can find the length as well. So rotating it, we have something like this here. So we need to measure this length to find the third side. Now measuring it, we have 1, 2, 3, 4, 5, 6, 7, 8. The subdivision, we have 0.1, 0.2, and 0.3. We have 8.3 units here. So which implies that when we have a right angle triangle, the right angle triangle is going to have sides as shown. Let's call this side A, let's call this side B, and this angle between the two sides, which is right angle, any side that is facing it, let's call it C. That C is known as hypotenuse. Hypotenuse will be the longest side. Hypotenuse is the side that is facing, or the side that is opposite to right angle. That is how to find hypotenuse. When you cannot easily visualize the longest side of a triangle, just go ahead and look for your 90 degree. Any side that faces it is hypotenuse, which is C. Now, from my previous explanation, we can see that this side, which is hypotenuse, the square is equal to square of when you add the other side together. So which means that this side C will be square root of the square of this and this. That is what we want to verify. And that is what I've shown you earlier on. Now, can we verify this using this? Yes. This is the hypotenuse that we want to measure. We've measured it, which is 8.3, using this graph. So we have measured it 8.3. Now let's now use our expression to find out if we are going to get 8.3. So this is a right angle triangle that we want to know this third side. So let's find it. C square, this third side that we don't know, is equal to 5.4 square plus 6.3 square. C square will be 29.16 plus 39.69. The square of this is 39.69. Press the calculator. The square of this 29.16, 39.69. So let's add it together. So C square will be 68.85. When you add these two guys together, you get 68.85. What will be the square root? C will now be the square root of 68.85 and is 8.2976. Wow. If you approximate 8.2976, what are you going to get? 8.3. We will still have error here because we are human beings, but our answer is too close for not to be true. So 8.3, 8.2976. Wow. That shows that this expression is actually verified. Lastly, let's look at another approach. Since here to here we've known it, which is 6.3, and we have angle here, angle in between this hypotenuse and this vertical line here, and it's going to be the same thing with angle here, because we have alternate angle. This angle is still the same thing as this angle. The same thing with this angle here will be the same thing as this angle here, alternate angle. So let's call this angle alpha, and let's call this angle beta. So this one will also be what? Alpha, and this one will also be beta. We know that alpha plus beta is equals to 90 degrees. If this is 90 degrees, the addition of these two will also be 90 degrees, because sum of the interior angles of a triangle is 180 degrees from Euclidean geometry. Now, we want to form another right angle triangle. We know this length as 6.3, so let's try and use this small part to form a right angle triangle. So let's measure our length. This length is 2.9. Let's count it. Why is it 2.9? We have a box here, 1. This one is 2. Now let's count the remaining, the subdivision. We have 1, 2, 3, 4, 5, 6 here. And we have 1, 2, 3 here. So 6 plus 3, 9. So 2.9. So this length is 2.9. This one we've known it before as 6.3. So we want to find this length. So we need to rotate it. Now we are going to rotate this anti-clockwise. We can't rotate it clockwise because it is going to move out of the screen that you are seeing. So let's rotate it in anti-clockwise direction. So rotating in anti-clockwise direction, we are going to have this. So let's go ahead. Now observe how we are measuring this. You can see that to construct a triangle, we need a compass. It's as if while constructing any triangle, we just need a compass, and we need a pencil, we need a fixed point, and we start moving around. That is what I'm showing. This is the knowledge of construction in mathematics. So they will just ask you a question, find the construct triangle ABC, where AB is so centimeter, CD is so centimeter, and this is an angle between them. And later on, they will ask you to measure one certain length. This is the tricks here, and that is what I'm showing you. Now, let's go ahead and measure this length. Measuring this length, let's count our box. 1, 2, 3, 4, 5, 6, 7. Wow, just 7. Let's verify if it is actually correct. 6.93 units if we use this formula. Now, why do we get 6.93? If we look at it very well, it is not actually 7. It remains small before it touches this line. So, but due to human error, so we got 7, and this one is 6.9. So let's verify that. 6 squared will be what? 2.9 squared plus 6.3 squared, and that will give us 8.41 plus 39.69, which equals to 48.1, and C will be square root of 48.1, which is 6.93. From our measurement, we measure 7, and here we go, we have 6.93, and 6.93 is approximately 7. We have a bit of error here, which is understandable. So we have verified Pythagoras Theorem. Wow, this is verification of Pythagoras Theorem. Now, Pythagoras Theorem, what is it saying? It's saying that when you have a right angle triangle as shown, the only side that you know the name is the one that is facing the 90 degree, which is called hypotenuse. So it doesn't matter if you have ABC or you have anything, just understand this. We are just using ABC as a convention. So your hypotenuse square will now give us what? The square of the other side, the addition of the square of the other side. So C square will be what? A square plus B square. So if I choose to use another convention, let's say I have A here, I have B here, I have C here. So it will be what? A square is equals to B here, B square plus C square. So don't just cram this convention formula. Understand it. Hypotenuse square will give you addition of the square of the two other sides. And C, the hypotenuse, is equal to square root of these guys. And we can also make the other side as a of formula. A square is also what? C square minus B square, hypotenuse minus Z. So we get what? C square root of this minus this. We also get, for B, we get this. So you can use this to find the third side of a right angle triangle. This is only applicable to right angle triangle. There's another way to solve triangle that are not right angles. But any method that is derived is actually from Pythagoras Theorem. We have Pythagorean triplets, sets of whole number that can be used to form right angle triangle. If you know this Pythagorean triplets, you might not really need to solve question before you fix the third side of a right angle triangle if the question is whole number. The first one is 3, 4, 5. Which one will be your hypotenuse? 5 certainly will be your hypotenuse. So 3 and 4 can be the other side. We have 6, 8, 10. 10 is the hypotenuse. 5, 12, 13. 7, 24, 25. 8, 15, 17. 9, 40, 41. We have many Pythagorean triplets. So we can also have multiples of this. For instance, when you multiply 2 by 3, we get 6. 2 by 4, we get 8. 2 by 10. 2 by 5, we get 10. So which means that you can have multiples of any of these Pythagorean triplets. Let's say I want to form another triangle here. I want to use this. I can just have 18, 80, and 82. It will form Pythagorean triplet. So that is that about Pythagoras theorem. Find the unknown side in a triangle shown below. So we want to use Pythagoras theorem. Solution. Let's observe a triangle. This is a right angle triangle. That's the first thing you need to understand before you start jumping into any question like this. Why is it a right angle triangle? Because of this symbol. And this side happens to be our hypotenuse. Why is the hypotenuse is facing this right angle? So it's facing it. So we have hypotenuse here. And don't forget your Pythagoras theorem. Hypotenuse square is equals to addition of the square of the other side. So we are going to have what? X square, which is the hypotenuse, will be 8 square plus 7 square. And what is 8 square? We have 64. What is 7 square? We have 49. And what is 64 plus 49? We have 113 as shown. So what will be the value of x? X will now be equals to the square root of 113. And what is the square root of 113? When you press a calculator, we get 10.63. And the answer is 10.63 centimeters. Very simple. Let's solve this question as well. This is also a right angle triangle. We have 23 being our hypotenuse. So it means 23 square will give us 15 square plus x square. We are looking for x here. So we are going to have, what is 23 square? 529 is equals to 15 square 225 plus x square. So 529 minus, you bring this 225, you bring it to the other side here. That's 529 minus 225 is equals to x square. 529 minus 225, that will give us 304. So which means 304 is equals to x square. So you can rewrite it. Rewriting this, you get x square is equals to 304. X will be square root of 304, and that's 17.44 centimeter. Now we've seen how we can apply Pythagoras theorem after we've proven Pythagoras theorem, or we can apply Pythagoras theorem to find the top side of a right angle triangle. If you haven't subscribed to this channel, kindly subscribe to this channel, like my video, share my video, and look forward to my next video, which is the continuation of trigonometry. Alright, thank you very much. Thanks for watching, and see you in the next video. Bye for now.